In this module, we are reviewing hardware and software basics. All computers, including your cell phone, are composed of hardware and software. They are two distinct disciplines within the engineering and computer science industries, but must work together seamlessly for computers and hence information systems to operate well. It is important as a business professional that you understand the basics of these components, as all businesses rely heavily on information systems to assist them in providing the goods and services they provide to their customers in more efficient and effective ways. First, let's cover some terms that is somewhat of a review of the course overview. The term information technology is being used to mean a wide variety of things, but essentially, at its core, information technology refers to any computer-based tool. The definition on the screen is very important because it links several key areas together: computer, people, information, processing, and organization. All of these components come together and must be organized in the context of their usage to be effective. A computer is composed of the elements identified on the slide. As a business professional, you should be aware of some of them, but we're not going to go into any depth of any of them. The primary concern of business management is speed, storage, and transaction throughput, which is how quickly a business can get transactions through a completed cycle from input to output to ultimately payment. Speed, or sometimes referred to as compute power, means how fast transactions are processed. You see this represented in the gigahertz rating. The iPhone 8 and 10, for example, are rated at a 2.39 gigahertz. That's pretty fast. Primary storage is related to speed, as the more data and processing that can be performed in the computer's primary memory, the faster the computer can operate and the higher the transaction throughput. Secondary storage is where data of information will be stored after it's processed. Don't be confused. When you see the price for a cell phone with 64 gigabits of memory, be careful. Is that primary memory or secondary memory? This it's usually secondary memory. Secondary memory does not improve the speed of the phone. It only provides the ability to store more music, pictures, and video on the phone. In the business world, secondary storage is now considered a service as opposed to an on-premises hardware requirement or component. Google Drive and Amazon Web Services are providers of cloud-based storage at very reasonable prices for businesses. This slide represents the components that make up every computer. It's just a pictorial overview of what was provided in a bullet list format. As mentioned before, CPUs are rated by speed, measured mostly in gigahertz today. This speed measurement, however, is primarily used for personal computers and devices like laptops, notebooks, and cell phones. This measurement still applies in some higher-end CPUs, but in business, with large computer requirements, their CPUs are measured in the number of floating point operation, or flops, which is a flop is a standardized mathematical algorithm that has been standardized globally. The faster the CPU, also the more expensive. This is a picture of the fastest computer in the world, which is manufactured by IBM. It's called the Summit, and it is made up of rows of black refrigerator-sized units that weigh a total of 340 tons. It has a processing speed, which is the ability to perform those mathematical computations, of 200 petaflops, which is equal to 1,000 million floating point operations per second. Yikes! To put that into perspective, if a stadium built for 100,000 people was full and everyone in it had a modern laptop, it would take 20 stadiums to match the computing firepower of Summit. As a business, you are unlikely to experience or need a supercomputer, but it's good to have this knowledge just in case. These types of computers are normally used for weather predictions or national defense. The Summit was built for the Oak Ridge National Laboratory in Tennessee, where the Department of Energy maintains a federally funded research and development center. We've already discussed the speed factors, but I wanted to draw your attention to the terms at the bottom of the screen: bit and byte. A bit is the smallest unit of data that a computer can process. A bit is represented by a 0 or a 1, which is essentially translate to a transistor, which is on a chip, being in the on or off position. All computers today comply with the American Standard Code for Information Interchange, which is also called ASCII, which defines the sequence of bits that combine to make a byte, then in turn represents a number or character. All software is decomposed down into the bit and byte level for processing by the CPU. For example, when you type the letter A on your keyboard, it is being translated into 01000001. That information is then processed through the CPU and primary memory. Pretty amazing. Primary storage is the storage that works directly with the CPU, as mentioned before, and can determine the speed of transactional processing, which is very important in the business world today. I've included random access memory because this is often represented in the specifications that you see on laptop computers and even cell phones. RAM is typically primary storage. However, it can be used as secondary storage, and you should be able to find the difference between the two. Some computer specifications also identify read-only memory, or ROM. Now, ROM is just the memory inside a computer that provides the instructions for how all the devices work together. For example, when you're typing in your keyboard, there is ROM that has preset instructions that tell the keyboard how that information is going to be input into the CPU. Typically, ROM is not replaceable and is predefined and preset with every computer. Secondary storage is measured in terms of kilobytes, megabytes, gigabytes, terabytes, petabytes, and exabytes. Whew, fast. Well, exabytes is pretty rare except for supercomputers. Most storage that we see today is in the gigabyte range. However, there are some laptops that are coming out with terabyte level storage. Input devices are very important. It's how we get data into computers. The devices shown on the screen on this slide are extremely error-prone and lack accuracy. Yes, the keyboard typically has a 10% error rate, as some studies have provided. So, there are other input devices that are much more effective and increase the accuracy. For example, scanners, and also your microphone. Voice to text and voice recognition are actually more effective and more accurate in entering vast amounts of information into computers. Then we have the output devices. The output devices listed on the screen here are the display units. The cathode ray tube you probably don't see. You might see one at your grandma and grandpa's house. They're really old. Even LCD is being swapped out for LED and OLED. Some other output devices are printers, plotters, and you can see the 3D printer is one of the newest versions of that output device, which is pretty cool. Lastly, what forms a computer is a communication device. The processing of data and information within a computer is useless unless we can share it with others and other computers and other people. So these communication devices are essential. Dial-up access, not so much anymore. Even cable and digital subscriber line, which is DSL, are on the not very popular anymore as well. As wireless or Wi-Fi as we know it is very popular. Satellite communication is becoming more popular, but there's a problem with satellite communication in that a computer is trying to communicate with a satellite that is hundreds of miles above the Earth, and then that signal must come back down to another computer. That time lag is called latency, and latency and computers don't go well together. I wanted to mention Moore's Law because Moore's Law, which was observed in 1965 by Moore, who worked for IBM, identified that computing prices are cut in half with every 18 to 24 months, just as the computing power doubles. So, computing power doubles, transistors increase, the amount of storage, the speed doubles, yet the price comes in half every 18 to 24 months. You probably recognize this yourself, that the TV or the device, computing device a year ago is probably much cheaper today than it was when it was originally introduced to the market. So, now, studies have shown that actually Moore's Law is closer to 9 and 12 months, not 18 to 24 months. But for the purpose of the class, we'll stick to 18 and 24 months. Moving on to software. Computers are great, but essentially useless without software. While hardware advances at a predicted pace based upon Moore's Law, software is more volatile and usually lags several years behind hardware. There are two main categories of software: system software and application software, as identified on the screen. Acquiring or obtaining software is usually done in three different forms. The first form is custom, which means organizations develop their own software. This is very expensive to build, maintain, and usually requires a staff of IT professionals to keep it up to date and provide enhancements. More popular is commercial off-the-shelf, also called COTS, which is primarily how we purchase our software or obtain our software today. This is more cost-effective, and enhancements and modifications are provided in a periodic manner, usually once or twice a year, depending upon the software and its application. A third type of software is called open source. Open source is essentially free software, but does require in-house expertise for sophisticated software and systems, which, when you have to hire that in-house expertise, can be just as expensive as COTS or custom. So you have to measure these things well within a business sector. The universal software of the world right now is the web browser. And of course, the most popular web browsers are Chrome, Safari, Firefox, and Internet Explorer or Edge. This chart depicts the global market share for the current browsers, with Chrome by far leading the way in popularity. I also wanted to mention the OSI model, because hardware and software, for it to be able to work together, there has to be some standards. And the OSI model is an international standard that is used by IT professionals to develop hardware and software so that everything is compatible. We also use this as IT professionals use this to help in troubleshooting and identifying problems and errors in both hardware and software. We usually start at the bottom and work our way up. Starting at the physical area, you would be surprised how many times we are told that there's a problem with a computer and it's not plugged in or not connected properly. It happens more than you think. It's kind of funny. In any case, this concludes our section on hardware and software. Hope you enjoyed it.